Hello, so we have a JEE Advanced 2025 paper 2 question. For the reaction sequence given below, the correct statement is R. So it's a multiple correct question. Okay. So we have a starting compound and this guy is reacting with few reagents to give us X. X is again reacting with few reagents to give us Y. Y is reacting with NaOH to give us aromatic compound plus Z. Okay, and there are few options which are given to us based on X, Y, Z. So obviously we have to find out X, Y, and Z. Only then we can proceed with these options. So the chapters involved is hydrocarbons, aldehydes, ketones, and carboxylic acid and amines. Okay, so to start with, alkyl benzenes, that is benzene ring attached to an alkyl group, that is I'm talking about these guys. So you can see R is an alkyl group which is attached to the benzene ring. So these guys, whenever they are treated with potassium permanganate, it results in oxidation to give benzoic acid. Okay, so whenever we treat them with KMnO4 in acidic conditions and heat, so ultimately we result or we get COOH. For example, if we have toluene, so this guy CH3 and yeah, benzene ring. So if you have KMnO4, so this guy will quickly become a benzoic acid, COOH, right? Next, we have to know about benzylic position. Okay, so benzylic position, it's a position which is directly adjacent to an aromatic group. Okay, important. Directly adjacent to an aromatic group. Okay, for example, let's say we have a benzene ring and we have a side chain. So this position is known as the benzylic position. Okay, this position directly next to a adjacent to a aromatic group, so this is known as our benzylic position. Okay. Next is, so since I mentioned that alkyl benzenes, whenever we oxidize them we get carboxylic acid. There is a catch here, that is the oxidation of alkyl benzene, that is these guys, to benzoic acid works only if there is hydrogen attached to the benzylic carbon. Very important. Okay, oxidation of alkyl benzenes to benzoic acid works only if there is hydrogen attached to benzylic carbon. Okay, obviously this I am talking about the alkyl benzenes. So okay, so this guy will be oxidized to your benzoic acid only if it contains a hydrogen attached to the benzylic carbon. Okay, so for example, let's say we have this alkyl benzene, that is benzene ring C, CH3, CH3 and CH3 and benzene ring. So can you see there is benzylic position, yeah, benzylic carbon, but there is no benzylic hydrogen, right? In toluene there were 3 of them, right? In this guy there is none. So therefore this guy, upon KMnO4 reagent, no reaction. Okay, so the reason why we need allylic hydrogen, or only those alkyl benzenes, those contain hydrogen attached to benzylic carbon, show this, because the answer lies in the mechanism. Okay, so the mechanism of this reaction is a bit important, that is H plus comes from the acidic KMnO4. Remember I told you that we have H plus also. Okay, so this H plus will react with the MnO4 minus ion of acidic KMnO4 to give us MnO3 plus, sorry, minus and H2O. Yeah, so this should be plus. Okay, so we get this ion when the acid reacts with the permanganate ion, and this MnO3 plus, this guy is responsible for attack on the alkyl benzene. So let us take this guy MnO3 plus is attacking our alkyl benzene. Let's say we take toluene, right? And I'm writing toluene in this fashion. Okay, So what does this guy do is it creates a free radical, that is, in from this pair one electron goes to CH2, the other electron goes to H. Okay, so showing by arrows. So we get a benzene ring CH2 free radical, benzyl free radical, and we get HMnO3 plus. Okay, so you can see this reaction proceeds, or this reaction is a free radical reaction, right? Because free radicals are being formed. And if a benzylic hydrogen is present, that is, for example, such kind of hydrogens, it will result in a benzylic free radical, that is this guy. And we know that benzylic free radicals are extremely stable due to resonance, so they are resonance stabilized. Okay, so therefore this reaction proceeds only if, you know, benzylic hydrogens are there. In this case there were none, so therefore it could not form the benzylic free radical. And when we, you know, get this benzylic free radical, so this guy will again combine with the, so this guy will combine with, radical will combine with this HMnO3 plus, react with this, and we will get alcohol plus, you know, Mn5 compounds. And this alcohol, since it is, you know, oxidizing conditions, it will be oxidized to benzaldehyde, and then so benzaldehyde will look something like this, and this benzaldehyde will be ultimately oxidized to benzoic acid. So this is how it happens. Okay, this is how the mechanism works. So we get benzaldehyde, and then we get benzoic acid. Okay, so this is the first example. Let's take one more example of an alkyl benzene, that is benzene ring and a bigger, you know, side chain or a longer side chain, right? So when we treat such kind of alkyl benzenes with KMnO4, so obviously reaction is going to happen because it contains two allylic hydrogens. So yeah, it is going to happen. But the catch is, irrespective of the length of this chain, okay, we will get a benzylic free radical. And also the cleavage of the side chain will happen, very important. By cleavage I mean, so here we have two hydrogens. So this bond is going to break, and this hydrogen is going to take form a free radical, and this is going to form a free radical. So we will end up with again a benzyl free radical. CH dot, and this guy will ultimately give us the benzoic acid, right? So therefore, irrespective of the length of the chain, we always end up with benzoic acid because of the formation of a benzylic free radical. Okay, so we will get this, and also, you know, cleavage happened here, so we will get C double bond O H. Okay, cool. Now let's come back to the question. So in our question we have the starting compound as this, that is benzene ring fused with a hexagon. Okay, so the name of this guy is 1234 tetrahydronaphthalene. Tetrahydronaphthalene. Okay, so can you see this guy has two available or two different benzylic hydrogens? You know, this location is one, this is other location, right? And we are treating this starting compound, or, you know, 1234 tetrahydronaphthalene with first reagent is KMnO4 H plus and heat. So this guy, first reagent is KMnO4 H plus and heat. So what's going to happen? Obviously the bond is going to break in these positions, and H is going to, you know, take an electron to form H free radical, and this is going to take to form a C free radical. Same thing happens here. H takes one free radical, and this carbon takes one electron to form a free radical. So showing those like this, this is where the cleavage happens. This H, this H, this H, and this C. Okay, so therefore we will be, you know, getting this carboxylic acid. So we will get Therefore the major product will be benzene ring, C double bond OH, C double bond OH, right? So this became a carboxylic acid, this also became a carboxylic acid group, and the cleavage happened here. So we'll be getting this. The name of this guy is phthalic acid, okay? PHTH, phthalic acid, okay? And the second step that we do with this is we treat it with ammonia, heat, and also there is loss of 2 molecules of water, okay, important. So carboxylic acids, that is, RCOOH, are acidic, and so this guy is acidic, and also ammonia is, basic. So therefore an acid and a base will react to give us salt, right? In general, we can write RCOOH, whenever they react with NH3, they give us RCOO minus and NH4 plus. These guys are known as ammonium salts. And if we continue to heat, what will happen? Obviously we will lose a molecule of water, and ultimately we'll be getting amide and a molecule of water, right? So in this case also we are reacting this phthalic acid with ammonia, so we will get the corresponding ammonium salt. So the ammonium salt will look like this. So we'll get benzene ring, C double bond O minus and NH4 plus, C double bond O minus and NH4 plus. So this is known as ammonium phthalate, okay? Ammonium phthalate. And then we are again, heating it, right? We are heating the ammonium phthalate because NH3 heat, then there is loss of 2 molecules of water. So we are heating it. Because of the heat, we are losing 2 molecules of water. So ultimately we will, lose 2 molecules of water from here, 1 O from here, 2 molecules of water from here, 1 O from here. Therefore we'll end up with amide, and that amide will look something like this. So we will get benzene ring, C double bond O NH2, C double bond O NH2, and this guy is known as phthalimide. So therefore, this guy is our X. So we found what is X, okay? And then we do the first thing with X is, strong heating, okay? So whenever we do strong heating, the first thing that we do is strong heating. So upon strong heating X, what will happen? We will lose a molecule of ammonia, okay? So let's say NH2 from here and 1 H from here. So we will be getting a compound like this. Okay, and this guy is known as phthalimide, okay? Phthalimide, and this is phthalamide, this is phthalimide, okay? There is a difference. This is amide, this is imide, okay? Cool. So this is what we got after doing the first reagent with X, okay? And after this we enter the Gabriel phthalimide reaction zone, okay? So after this Gabriel phthalimide reaction is going to happen, okay? Cool. So the second reagent that we treat this phthalimide is with ethanolic KOH. The second one is ethanolic KOH, okay? So obviously this will contain a negative charge, this will contain a positive charge. This guy, KOH, K is positive, OH is negative. So what's going to happen? H plus, OH minus comes out in the form of water, and this K is becoming, gets attached to the N. So we will get C double bond O, C double bond O, N, and N minus, and obviously K plus. So this guy is what we get after, ethanolic KOH with phthalimide. This is known as potassium phthalimide. Potassium phthalimide. Okay. Then the third reagent that we use here is, the third one is RBR. Okay. And this reaction is nucleophilic substitution. Okay, so what's going to happen, this is the nucleophile, and Br contains, partial negative charge, R contains partial positive charge. Okay, so this guy is going to come and attack our R and form bonds with R, and K and Br is going to go out. Therefore, after the nucleophilic substitution, we will be getting the product as, we will get the benzene ring, C double bond O, C double bond O, N and R, and plus KBr, right? And this is, Y. How did we get this? Simple. Nucleophile attacks R, so R will form a bond with this nucleophile, and Br and K out. That's how we got this. And this guy is known as N-alkyl thilimide. N-alkyl thilimide. Okay, there is a catch, and there are some conditions on, what R can you use. You cannot use any R. R can be aryl as well as alkyl. Okay, and also R can be primary, secondary, tertiary. Okay, so therefore, since it is a nucleophilic substitution reaction, okay, this R cannot be aromatic or a aryl group, because we know that aromatic or haloarenes, these guys, they don't undergo nucleophilic substitution, or you can say they are extremely less reactive. So therefore, R cannot be aromatic. That's the first condition. And also, R, since we are doing nucleophilic substitution, incoming nucleophile is going to attack R. So that's why we want very less crowd around R. So therefore, we cannot use a secondary or a tertiary R group, alkyl group. So therefore, R has to be primary also. So these are the two conditions. R cannot be aromatic, and also R 1 degree is preferred. Okay. So these are the two conditions. And then Y, to Y, we react Y with NaOH. Okay, so this is, alkaline hydrolysis. So what will happen? So ultimately we will get benzene ring, C double bond O, C double bond O, O minus Na plus. These are the, sodium salt of phthalic acid, and R NH2. Yes, so whenever Y is treated with NaOH, so we'll be getting this sodium salt of phthalic acid and RNH2, where, since R is a primary group, so that's why it is a 1 degree amine, and it is non-aromatic because R cannot be aromatic. So this is 1 degree non-aromatic amine. So these are the, conditions of Gabriel thilimide reaction. Okay. So now we can look into the options one by one. Okay. So we know what is X, Y, Z. So this is Z, and this is the, aromatic compound which has formed. We know X and Y. Okay. So let's look at options one by one. So X we know is this guy, benzene ring, C double bond O, NH2, C double bond O, NH2. This is X of thilimide. This is X. Then Y that we got is benzene ring, C double bond O, N, R, C double bond O, N, R. Right, and this is, known as N-alkyl thilimide. Right, so the statement A is both X and Y are oxygen containing compounds. Correct, it contains oxygen, it also contains oxygen, so therefore A is a correct statement. Okay, cool. Let's go to statement B. B is saying that Y on heating with chloroform oblique, in the presence of potassium hydroxide forms isocyanide. Okay, so this is Y. So whenever we are heating this with chloroform and KOH, so you can see, whenever you have an alkyl thilimide, that is Y, and you heat it with NaOH or KOH, so we get a, aromatic compound and primary aromatic amine. Sorry, primary amine, which is non-aromatic, right? So therefore, whenever you will treat this guy, that is an alkyl thilimide, with, in the presence of KOH, so we'll get a primary non-aromatic amine, that is RNH2. And primary amine will react with this chloroform to produce isocyanides or, carbonyl amines. Okay, So RNH2 will react with CHCl3 and KOH, alcoholic, to give us RNC plus KCl plus H2O, right? So this is, our isocyanide or carbalamine. So this is also known as carbalamine reaction or isocyanide test, right? So therefore, yes, Y will react with chloroform and KOH to give us isocyanide. So this is a correct statement. Okay, so B is also a correct statement. Next we have statement C. Statement C is saying Z reacts with Hinsberg's reagent. Z is RNH2, right? So it is a primary non-aromatic amine. So I can write RNH2 as RNH and H separate, plus Hinsberg's reagent is benzene sulfonyl chloride, that is this guy, S double bond O Cl. So yes, so these two are going to react H and Cl out in the form of HCl, and we get benzene ring, S double bond O, N, H and R. And these guys are in general known as N-alkyl benzene sulfonamide. Okay, so therefore yes, Z reacts with Hinsberg's reagent, so therefore C is also a correct statement. Okay, and the last statement is D. D is saying that Z is an aromatic primary amine. Okay, Z, that is RNH2. We have just discussed that it is a primary amine, but it is non-aromatic, because how is Z formed? Z is formed by the reaction of this guy with RBR. Remember, that's how we introduce R. Okay, and so this is a nucleophilic substitution reaction. So this guy is going to attack our R. So therefore, due to that, R cannot be aromatic. It cannot be a aryl group. And also R cannot be a secondary or a tertiary group, because too much crowd, not good for us. Okay, so therefore R has to be 1 degree and also non-aromatic. So therefore the resulting RNH2 will be a primary amine which is non-aromatic, right? So therefore statement D is incorrect. So therefore this is incorrect. So therefore A, B, C are the correct answers. Okay, so this is the correct answer, this is the correct answer, this is the correct answer. Okay, thank you.